go. Hello, Mr. Right, are you right?
Yeah.
Do you still remember the linked list? Yeah, linked list, like linked list. Linked list, yeah. One is there is a head, yeah. And then there's a full stop, then we put it a none here. Okay, the linked list could be one direction or both direction. If we call this finger one direction, if a node points to next, we call it singlet. Singlet, yeah, singlet. If it points both way, we call it doublet, yeah? Makes sense, yeah? Doublet, okay. So today, given a singlet linked list, yeah? Singlet. We want to delete the middle of it. Delete the middle of it. So what's middle? So the first node is the index is 0. The second is 1, 2, 3, 4. And we want to delete the middle list, which is the last index, like, and divided by 2. This means that to get a floor. Right? Look, what's this symbol? Look, that's floor. That's ceiling. Make sense? Like this. Ceiling 3.2 equals 4. Floor 3.2 equals 3. Okay? Make sense? Yeah? This means the rounding up. This means rounding down. Okay? So this corresponds to the CEIL. This corresponds to floor. Yeah? Or int. We can convert to the int. Okay? Yeah? So look, 3 divided by 2, 1.5. Ceiling. Ceiling, which is what? Okay, so actually, this is to be the number of the floor nodes, which is 1, 2, 3, 4. Yeah, 4 divided by 2. So that we want to remove this node. We want to remove this node. This is the middle node. Right? Even there are 4 nodes, and this 2 is the middle of it, because according to this, yeah, the number of nodes divided by 2 get us floor. Okay. How about the odd number of the nodes? 1, 2, 3. There are 3 nodes. 3 divided by 2, floor equals 1, right? So the 1, what's 1? 1 is this is the middle, 0, 1, 2, okay? Make sense?
Yeah.
Do you still remember how do we find the middle node? I think this. How do we find the middle node? Let's say we want to find the middle node. How do we find it? Any idea how do we find the middle node? How do we find this middle node?
Just, I don't know, 2 pointers.
Yeah, 2 pointers. Okay, what are these 2 pointers?
1 and 7 at the end.
But then it doesn't work this way, right? Because the pointer at the end, you can't point both ways. Right? When the end, you can't go back. There's no way to go back. So 2 pointers. Yeah, I have 2 pointers. Do you still remember?
One goes double than the other.
That's right. One is fast, the other is slow. Fast goes 2 steps at a time. Right hand, yeah? Look. Right hand fast. Left hand slow. Okay, go. 1, 2. Go. Go. 1, 2. Go. Okay, you can't go any further. It reaches then. So the slow is the middle. Got it?
Go.
Yeah?
Dun, dun.
Go.
Go.
Dun, dun. So fast and slow. Fast and slow. Sometimes we call it the rabbit.
Dun.
Rabbit, turtle. Turtle.
Oh yeah, that's when
How do you say the turtle in what's this word?
Tortoise.
The turtle. Turtle, this is one word, and another one is something like that, right? I can't. Yeah, tortoise. Rabbit, turtle. Rabbit and turtle having a race. Yeah? The rabbit runs very fast, but rabbit is very proud, or rabbit is very
Show off.
yeah, show off, yeah. And then rabbit thinks, okay, I'm so fast, yeah, I can win anyway. So rabbit just takes a nap, but the turtle was keep walking and pass the rabbit and wins. Do you get it? So what do you learn from this story?
Don't show off.
Don't show off, and don't look down on your opponent, right? Because if you are having a race, then your opponent is not, then the opponent will eventually, win. Yeah, do you get it? Okay, so yeah, you're raising a very interesting point, which is the fast and slow pointer. So okay, so suppose we have a list. I have already know this slow pointer. How do we delete this now? How do we get this thing out of this chain?
Just delete it.
Delete it. So what do we need to? How do we delete it?
I don't know.
How do we need access to the previous now? Yeah, if I have access to the previous now, I can point here the next to this thing dot next, right? So eventually you'll be sent as cutting off, and then I can delete this, right? So if this is previous, so I can just say previous dot next equals previous dot next equals slow dot next. Previous dot next is originally pointing to slow, right? Then I repoint to slow dot next, and then I can remove the slow. Make sense? Yeah? Got it? Make sense? So we need to keep tracking on the previous by walking. So every time we walk, the fast, dum dum. Yeah, slow, dum here, but the previous is here. Dum dum, dum. The previous. We always remember the previous, right? Update. Okay, and then let's quickly write it. That will be easy. It will be easy. Yeah. So we have to handle a special case. What special case? When the node is only one node. If this is one node, if we remove this, what happens? What's the middle node? It's itself. So if we remove it, it will become empty. Yeah, empty. Yeah, which is empty. Yeah, empty.
Yeah.
If there are two nodes, what should we return? Which node we are going to remove? Which one is the middle node?
Second.
Yeah, because there are two nodes. 2 divided by 2 floor. That's equals 1. 0, 1. Okay, index 0, 1. Okay, so it become 1. Okay, this is two special cases. Okay, let's do it. Define, remove middle, and we have this head. Yeah, head. If not head, return head. Yeah. If we are given nothing, we just return it as it is. If not head dot next, right? If there's one single node, then we just return head dot next. Yeah, easy. Yeah. Okay, this is two special cases. If nothing, then return nothing. If there's only one single node, then return one single node. Now, okay, previous node equals nothing first, and then we have a fast equals slow equals head. Okay, while fast dot next. Okay, while fast dot next. While fast dot next. Then we do what? Slow. Fast equal 2 steps at a time, yeah? Fast dot next, right? Yeah? That's fast. And before we move the slow, we need to store the value of current slow into the previous, yeah? So previous equals slow, yeah? Okay? Now, okay, fast dot next, right? So here, fast dot next is none, so it's the last node. So we do what? Look. Previous dot next. That's how we delete it. Previous dot next equals slow dot next. Because slow is the middle node now, right? Yeah? Alright?
Yeah.
This is previous. This is slow, which is the middle. This is the middle, yeah? We want to remove this middle node. Yeah? Yeah? This is slow dot next, yeah? Slow dot next. Dot next. Okay, so look, previous dot next equals slow dot next. So what did I do now? So look, after this, I change it here. Previous dot next equals slow dot next. Yeah. Then I can delete this now, right? Yeah. Delete. DEF. Look, this is a new thing you need to learn today. Delete. DEF stands for delete. Means to remove it. To remove it. Yeah. So remove it. So just delete slow. Yeah. And then we just return the new head, which is the head. Okay? Yeah? Okay, so Eric, Ryan, this bit, Yeah, you see? This bit, Eric.
Mm.
This bit. Yeah. This we have learned it before, yeah? This bit. So today, this is the new thing. Yeah. So, I mean, actually, here we need to. How do we delete it? We want to delete this slow, the middle node. We need to know the previous node, right? Yeah, we need to know previous node. And how do we find the middle node? Fast and slow. Yeah. The rabbit and turtle. Rabbit, speed 2. The turtle speed 1. Yeah. Alright. When the rabbit reaches the end, the turtle is where is the position of the turtle?
In the middle.
In the middle, yeah, in the middle. So we are in the middle. The turtle in the middle. So before we move it, we need to have this previous. Yeah, previous dot slow, previous equals slow. We remember the position of the middle and then the okay, so I think previous equals slow. Okay, there is one condition. Slow equals slow the next. Okay. Yeah, we move. We need to move. Fast equals fast. No next. Slow. Okay. And then we delete it, return it. That'll be, yeah? The time complexity, if we like n nodes, the time complexity is O what? O what? There are n nodes of the singlet, O and O and. The space complexity, we're not using any additional space, yeah? Instead, we remove one space, okay? Yeah, that'll be, say bye bye to people.
Bye.
Bye bye.